Okay, welcome back. In the last video we went over example 1, and that was a case 1 example where we had a top function and a bottom function. We're now going to move on and look at example 2. It says find the area enclosed by x equals y squared, y equals x plus 2, y equals negative 2, and y equals 3. And one thing that gives away that this might be a case 2 problem where we have a left function and a right function is the fact that one of these functions is given in terms of x equals instead of y equals. But let's go ahead and graph these just like we did in example 1. Let's go ahead and graph them and see what we get. So I'm going to go back to Desmos here. We'll go ahead and put these in. We have x equals y squared for our first one. And our next one is y equals x plus 2. And then we have y equals negative 2. And then we have y equals 3. And if you go ahead and look there definitely looks to be an enclosed region that's enclosed by all 4 of those curves. Some points of interest, some of those intersection points, there's a lot of them, but one of them it looks like would be 1, 3. Another one I would say looks like to be 9, 3. Then we also have negative 4, negative 2. And then we also have 4, negative 2. And we want to go ahead and put that graph in our notes. But just looking at the graph here, you can see that this is definitely going to be one where we have one curve, in this case the blue one, which was y equals x plus 2. That blue curve, for this area, the blue curve is always on the left, and then the red curve, x equals y squared, is always on the right. If we think about going bottom to top, well, over here, the blue curve's on top and the green curve's on the bottom. But then when you get over here past 0, okay, well down here, the green curve is on the bottom and the red curve's on the top. But then up here, the red curve's on the bottom and the blue curve's on top. And then when you scoot over a little bit more, the red curve's on the bottom and the purple curve's on the top. And so it'd get really complicated. We have to split up our integral into a bunch of different parts and different functions on the top and the bottom, and we just don't want to do that. It's just too complicated. It's much easier to treat it as a left to right instead of a bottom to top like we did in the last one. So I'm going to go ahead and go back here to the notes, and let's go ahead and sketch this graph real quick. So do that. Put our axes on here. And start putting some of these curves in. So the first one I would say is let's go ahead and graph that horizontal line, the y equals 3 line. So that's y equals 3, and then y equals negative 2. Y equals negative 2. And then we had that line, some of the interesting points. One of them was at -4, -2. -4, -2. And then another one was at 1, 3. And that line went between those 2 points. And then we had our other curve, that kind of sideways parabola, x equals y squared. It had a vertex at 0, 0, and then it went all the way out to 9, 3. 2, 3, 4, 5, 6, 7, 8. Let's just say it's somewhere out here. That was at 9, 3. Then we had another point at 4, 2, 4, -2, excuse me. 4, -2. So this kind of looks something like this. And this one, this. So this was the curve x equals y squared. And then this was the curve y equals x plus 2. All right, and so the area in question, as we said, is this area in here. And we said that we're going to think of this as a left to right. So our representative rectangle is going to go this way. It's going to go from left to right, which means we're going to have a dy in this case. So let's go ahead and, because it's dy, that means everything needs to be in terms of x. Now this first equation was already x equals y squared, but we need to go ahead and rewrite the second equation. In this case, we have x equals y minus 2. And our area is going to be the integral from, okay, so now we're dy, remember it's dy, so we're going to go along the y-axis from -2 up to +3. We're going to go from -2 to +3. And then we're going to take our right function, which is y squared, x equals y squared, minus our left function, which was y equals x plus 2, but we solved that for x equals y, so for x equals, which gave us y minus 2. And that's the integral that's going to give us our answer. Let's just make one little note here. Again, this is our top function. And then this was our bottom function. Well, I had that backwards. Hopefully you guys were catching me. No, it's not top and bottom. What was it? It's right function minus left function. Okay, so that's what we got. And then from there, you can just integrate. I'll go ahead and do that real quick. I'm going to go ahead and clean this up just a bit. So we have -2 to 3. Distribute that negative sign, so we get y squared minus y plus 2. And then take the antiderivative, so we got 1/3 y cubed minus 1/2 y squared plus 2y, going from -2 to 3. And then when we go ahead and plug our limits in, we get 9 minus 9/2 plus 6. And we plug in -2, and we get -8/3 minus 2 minus 4. And this ends up being 21/2 minus, this is negative 26 over 3, which gives you 115 over 6. And that's our answer. You may be wondering how I was able to get those answers, those fractions so easily. If you've never done this before, let me show you real quick on the graphing calculator. So doing these calculations in the calculator, I'm going to get 9 minus 9 halves plus 6, which gives us 10.5. And then if you hit the math button and then option 1 there for fraction, you get 21 over 2. And then we have negative 8 over 3 minus 2 minus 4. Turn that into a fraction. You get negative 26 over 3. And then you just go 21 over 2 minus a negative 26 over 3. Turn that into a fraction. You get 115 over 6. And that'll do it. So I don't have anything else for this video. You should be good enough to go ahead and start the homework. I will post the solutions for this extra practice problem so you can see one more problem worked out, and let me know if you have any questions. Thank you.